Excessive moisture and instability of temperature are the main reasons for defective molding. Flow rate, temperature, dew point, and pressure are the main elements affecting the quality of drying in the molding process. Matsui's dryers contribute to the maintenance and enhancement of molding quality of all materials by providing the optimal condition for molding while taking into consideration the effect to the environment and usefulness of the equipment. Matsui's dehumidifying dryers use the honeycomb rotor-type absorbent and is of high functionality. It adapts the technology of flow rate optimization that contributes to the saving of energy. Drying using molecular sieves brings down the volume of wind when the molecular sieves break down into powdery form. During exchange of absorbent materials, unstable absorbent efficiency leads to problems such as unstable dew point. In order to eliminate these problems, Matsui developed the honeycomb rotor. The honeycomb rotor is made up of 3 zones, namely dehumidifying, regeneration, and cooling. The dehumidifying zone absorbs air moisture charged into the hopper dryer. The regeneration zone heats the moisture absorbed by the dehumidifying zone to evaporate it and hence regenerates the honeycomb rotor. The cooling zone cools the honeycomb rotor that was being heated during regeneration to an optimal temperature for dehumidification. These 3 zones enables the honeycomb rotor to provide a stable low dew point and a functionality like that of when first used. It is unnecessary to change the absorbent materials, and absorbent tower is resistant to influence of seasons and regions. The energy-saving technology of flow rate optimization controls the flow rate of dried air that varies with the temperature of exhaust dried air and the flow rate of regeneration air that varies with the temperature of regenerated exhaust air. Reducing the unnecessary usage of energy for drying and regeneration and using of heater that consistently adapts to the operating conditions helps to reduce energy usage. Matsui provides a wide range of drying equipment. The MJ3 series that has dehumidifying dryer and conveyor made compact into a single unit. The DMD4 series that supports optical molding, and the DMZ2 series that has a variety of sizes to cater to the different needs of our users. MGD combines both the hot air dryer and vacuum conveyor into a single platform. It is an easy-to-maintain floor-type equipment. Using a 2-tire hopper, stability of temperature is enhanced and contributes to energy saving. A regular cyclone filter of MGD is made up of filter case, separator, and dust box. The structure minimizes the clogging of filter and ensures stability in conveyance of materials. MGD can be opened from both the front and side, making it an easy to clean and maintain equipment. HD2, the standard model of hot air dryer, is also available to cater to all kinds of needs. The thermal conduction vacuum dryer, DPD3, dries materials by increasing its temperature as a result of heat conduction via thermal conducting fin. The effect of vacuum and conduction increases efficiency and shortens drying time. As compared to hot air drying method, half of the energy used can be saved. DPD3 recovers gas emitted during drying and is an environment-friendly equipment that reduces both exhaust gas and heat. PMD, which is attached on the molding machine itself, is most suitable for small-scale molding. Using the energy-saving conduction method, PMD reduces emission of exhaust gas and heat. PLP is a conveyor that conveys via a slim diameter pipe. As compared to regular hose of 46.5 mm in diameter, PLP's diameter is only of 16 mm. It can be used universally and supports multi-directions conveyance. As feed controller attached to dryers with space-saving tubes and clear terminal attached on the molding machine, PLP is of a small footprint optimal for small-scale molding. Matsui's MC series gives priority to the safety aspect and uses high level of technology to provide a stable environment for temperature control. Fluctuation of mold temperature is the cause of most defective end products. Mold temperature controller that directly controls the temperature of the mold has a great impact on the quality of end products. MC series consistently maintains a stable temperature of the mold. A variety of models are available with varying pump volume and temperature range to cater the varying needs of our users. It is very important to minimize negative environmental effects and reduce cost of production of plastic molding. Spur runners, which were commonly known to be waste products of plastic molding, can now be an important source of reusable materials. Using granulators and blenders that are both environment-friendly and of high functionality, Matsui proposed a recycling system in a factory that reduces waste materials and material usage. Low-speed granulators are dedicated to the recycling of sprue runners. Granulated materials with minimized miscuts and powder ensure stability in the quality of end product and hence contribute to the reduction of cost. Sprue runners are first cut into smaller pieces by the low-speed large rotating cutter, then granulated into smaller uniformed size by the small rotating cutter. High precision of processing, highly durable chambers and blades ensures the uniformity in the size of granulated materials. Formation of powder and noise pollution during granulation is being minimized with the screenless structure. The capacity of motor ranges from 0.75 kilowatt to 2.2 kilowatt. The ability to be opened widely supports easy cleaning. The reduction in time used contributes to the lowering of running cost and prevention of contamination. Low-speed granulators are dedicated to the recycling of sprue runners. Granulated materials with minimized miscuts and powder ensure stability in the quality of end product and hence contribute to the reduction of cost. Sprue runners are first cut into smaller pieces by the low-speed large rotating cutter, then granulated into smaller uniformed size by the small rotating cutter. High precision of processing, highly durable chambers and blades ensures the uniformity in the size of granulated material. Formation of powder and noise pollution during granulation is being minimized with the screenless structure. Capacity of motor ranges from 0.2 kilowatt to 2.2 kilowatt. The ability to be opened widely supports easy cleaning. The reduction in time used contributes to the lowering of running cost and prevention of contamination. In addition, granulator for elastomer MGL2-TPE is also available. A blender blends the natural and granulated materials together according to the specified ratio set. Blenders differ according to their measuring methods, which are measurement by ratio, volume, and mass. Upon connected to the conveyor path, JSV alternates the discharge between two materials and hence supports a simple blending of materials. The compact design minimizes the space it takes up. JCT-102PP measures at 2 points with its cup-type mass damper. Its simple structure ensures ease in cleaning and changing of materials. JCT-102SS measures and blends at the same time using its screw feeder structure. Upon setting the blending ratio, the supply volume can be calculated by the automatic arithmetic calculation function. JCW2 measures materials that are put through the measuring hopper at the load cell. This enables constant surveillance of the operating condition. Upon occurrence of error, immediate feedback contributes to the traceability of source of trouble and quality control. In addition, every measured volume can also be saved for record purposes. Depending on the blending method, JCW2 is available in both blending just before charged into the molding machine and the built-in blender. For blending of a small amount of material, aero power hopper that uses the current of airflow is extremely efficient. The SP type that is attached on the molding machine mixes only before the materials get charged. As such, it consistently ensures a charge of well-mixed materials. The JB type puts both measuring and blending into a single machine. JCW2 30, 60, 90 series are blending equipments that uses the mass measurement method, which is capable of handling a greater volume of materials. A regular machine that can mix up to 6 different materials at the same time while providing a stable mixing of materials. The auto shutter with a 3-stage control function enables high speed and high precision measurement of materials. In addition, the use of energy is only 1/10 of that of air cylinder. It is an extremely environment-friendly equipment. This allowed batch size to be halved and height of machine to be dramatically reduced. Size is reduced and performance is improved. After measurement, it is essential for the natural and granulated materials to be well mixed. Aero power hopper uses the power of airflow to evenly mix the natural and granulated materials. It also serves to remove dust and hence further enhances the quality of end product.